Alright, well hopefully you have watched some of my previous videos where we've been talking about this thing called trigonometry and our trig ratios, sine, cos and tan, and we've used them to find the length of sides that we didn't know in right angled triangles. Well, this time we've got another right angled triangle problem, but this time we're trying to find the angle. We're not trying to find a side. We want to know what's this missing angle. Let's have a look at our scenario. We've got a road that rises at a grade of 3 and 10. So what that means is for every 10 meters along the horizontal, it goes up 3 meters. So it gives us a slope. Think of like, you know, a massive big ramp, except it's a road. So it's got a what we call a gradient. So it goes up. We want to find this angle. We want to find the angle that is the steepness, I guess, of this road. Okay, so we don't know the angle, so we use this Greek letter theta to represent our angle that we don't know, but we can use our trig ratios for this. Now remember, this only applies to right angle triangles. So in this case, to be totally correct, I'm going to pop the right angle symbol in here. Now, whenever you get a right angle triangle, usually it's only one of two types of questions. Okay, if it's a right angle triangle, it could be a Pythagoras question, like you might have been asked to find the length of this hypotenuse side, then you'd use Pythagoras. Okay, or SOHCAHTOA, in other words, our sine, cos, or tan trig ratios. It's usually one of those two types of questions. Now in this case, we're not wanting to find the side, so it's not a Pythagoras, we're dealing with the angles. So it's going to be this one. It's going to be a trigonometry question using sine, cos, or tan. Now, which one? Having a look at my triangle, I've got my angle. The side that's opposite is this one. Okay, it's not touching the angle. That's my opposite. This is my adjacent. It's the side that's touching or next to the angle, but not the hypotenuse. So if I look at this, I've got no information at all about my hypotenuse. So I can't use anything that's got an h in it. I can't use sine or cos because there's nothing, no information here. So this is going to be a tan ratio question. I've got an opposite and an adjacent. That's perfect because tan equals opposite over adjacent. Remember, that's what the letters in our little phrase stand for. All right, let's do this. Tan, it's going to be a tan question. So I'm going to write out tan of the angle equals opposite over adjacent. So 3 over 10. Now, we've got to this point before with other questions. However, this time I need to get the angle on its own. I've got tan of the angle, but I want to know the actual angle. So I'm going to show you just what's actually happening, and then I'm going to give you one little shortcut in a moment. I'm just going to slide this fraction across a bit to make some room because I want to bring this tan across to the other side. And when I bring a trig ratio across the equal sign, it becomes its inverse. So in this case, it becomes inverse. It becomes inverse tan. I'm just going to go back and do that again. When I bring the tan across, it goes from a tan to an inverse tan. And I've got the angle here on its own. This is something you put in your calculator. Now here's the little shortcut. If that little piece there sort of confuses you, dragging the tan across, technically you don't even have to. All you need to do is, if I'm going to find the angle, remember, I hit shift before tan, because on your calculator that's how you get this inverse tan. So it's the little, you'll see your tan button just above it is tan to the power of -1. That's your inverse tan. You get it by hitting the shift button first. So really all I've done here is I'm going to hit shift, tan, enter my fraction, and I get 16.699. Now one little thing, if you've seen some of my other videos or been in any of my classes, you know I'm like to put things in these brackets just to remind me, because I've seen people type this in wrong where they've done inverse tan of 3 and then the whole thing divided by 10. Just to be safe, put it in the brackets. Now that's a decimal. I could, if the question doesn't ask for degrees, I could put it like that. It's 16.699 degrees. But if I want to put this in into a degree form, and let's say we're going to round it to the nearest degree, all I need to do is hit my little degrees, minutes, seconds button, which a number of my students refer to for some reason as the bubble button. I guess it looks like lots of bubbles on there. So if you hit the bubble button, it will give you an answer in the form of degrees, minutes, and probably seconds, which are, you know, there are 60 minutes in 1 degree, there are 60 seconds in 1 minute. So this is a degree, 16 degrees, and then another apart, or a fraction of a degree, 41 minutes. Now, if I'm going to round that to the nearest degree, I'm going to look at this number and say, well, listen, if it's 30 or above, I'm going to round up. Because if there's 60 minutes, anything above 30 will be closer to the next one up. So in this case, that is closer to 17 than 16. I'm going to round it, and my answer is a angle. My road makes an angle of 17 degrees. Now, the same little work here, the same little process applies to any of these trig ratios. If it was a sine question, you'd do the exact same thing, except you would hit shift sine, because you'd be working with inverse sine. If it was a cos question, you would have inverse cos here, so you'd hit shift cos. But the process is exactly the same. Good job, you guys rock. Well done.